sections 7.6 and 7.7. Okay, that's really all there was to this. It's going to be a shorter test. I'm going to guess that this will be between 40 and 50 points. That would be my guess just by estimating. But we did a lot in sections 7.6 and 7.7, a real lot. So 7.6, we started and we began looking at standard form of functions, right? Because 7.5 was vertex form. Now, vertex form does not go away. We still need to know that. So in 7.6, though, we started by looking, we said, well, there's something called standard form, which we've seen and you've probably seen before. And then we also wrote vertex form out, but with the K on the right-hand side. All right, so those are the two forms that we had in 7.5 and 7.6, really. In 7.6, though, we really identified both of them and used both of them. Now, what are some things you knew? What are some pieces of information you knew about standard form? What's something you know about standard form? Now,
if A is positive, it opens up.
Okay. If A is positive, it's still concave up. That's true for any of these forms. Very good. Concave up. All right, this is also true for the third form that we're going to look at in 7.7, which I might as well just put that up on the board now as well. I'll put them all up so make it easier. So the third form was intercept form. So there's all three forms on the board. And yes, the first piece that Niall said is correct for all three forms. When A is greater than 0, the graph opens up. What about when A is negative? The graph opens down. Yeah. Okay? So we know that this indicates its concavity, the A value. What else about standard form? What's some information about standard form that you know? C is the y-intercept in standard form. 0, comma C is the y-intercept. Okay, I'm putting standard form on the left so we know what we're talking about. What else? What else do we know in standard form? Kelly?
The axis equals negative b over 2a.
Yeah, the axis of symmetry is x equals negative b over 2a. For sure. Anything else? Pretty much it. I mean, we could find the roots by using the quadratic formula, or by using the quadratic program, or by trying to factor, depending on which scenario we're looking at here. So again, ax squared plus bx plus c, that's the information that we know so far. Okay, those three pieces. How about the second form, that vertex form? From last test, you'd have to recall this information. Yeah.
If they use standard form,
Mm-hmm.
these specifically determines the sign of the x coordinate of the vertex. Is that how you can look at it?
For this, negative b over 2a gives you the x coordinate of the vertex.
Oh,
Not b, yeah. B is just a value on the, there's no definite value from b on the graph at all. It's h that gives you the x coordinate of the vertex in the second form. Directly, you know what I mean? So this indirectly gives it to you, but it's using negative b over 2a, because this is that dashed line that goes through the vertex. Okay? And the graph of this, again, looks, you know, we remember over here. There's your axis of symmetry right there. And remember, this is your y-coordinate right there. And this is concave down, so that means that a must be negative. Could that be like an example of a graph for this one? So yeah, the x-coordinate of the vertex is negative b over 2a. Say that comes out to be, let's see, 1, 2, 3 hypothetically. Let's say this is an x-intercept of 3, this dashed line. Well, that means that this is at the coordinate 3 comma something. You take the 3, you plug it into the function to get the y value of the vertex. What about the vertex form, the second one? What do we know about the vertex form? A quantity x minus h squared plus k. What piece of info do we know about that? Niall, what do you have?
The vertex is HK.
The vertex is always hk. All right, the vertex is hk. It's going to fall off the screen because this concave part is screwed up. All right, so in vertex form, h comma k is the vertex itself. We know some other stuff, but nothing that's really extremely useful right away. For example, if you think about this, if you want to find the y-intercept in vertex form, it's always going to be ah squared plus k. And let me show you what I mean. On the left-hand side, I'm going to put a little example over here. Say that's the example on the right-hand side over here. If I want to find the y-intercept, what do you do to always find the y-intercept? What's the rule of thumb? Yeah, you make x 0. Well, if x is 0, doesn't it just become whatever h is squared, which is 1 squared here, times 2 plus 4. So you get 2 plus 4, which gives you 6. Well, in reality, what are you doing? You're doing this. You're plugging in f of 0 into this. If you look at it in the regular vertex form before you plugged in any numbers, it becomes a h squared plus k. It's always going to be for the y-intercept. The y-intercept in vertex form will always be 0, comma, ah squared plus k. All right, again, it comes from the fact that when you plug in a 0, this is left behind as a negative h, but you're squaring it, which makes it positive h squared times a plus k. There it is over here, positive h squared times a plus k. That's always going to give you the y-intercept. You don't have to memorize that by any means, but it's good to recognize that. Okay, to always see that the 0 allows you to just take whatever h was, square it, multiply it by a, and add k to it. Okay. Anything else about vertex form? I mean, the a part obviously tells if concave up or concave down again. Same as standard form, that didn't change.
If h is negative, then it moves to the right. If it's positive, it moves to the left.
Well, what do you mean if h is negative? Use the example on the right,
But
not the standard one. Use the actual example with numbers. How would it move in this case?
so if it's h is positive 1, right? That means that the graph would be like slightly more to the right than a regular like quadratic like x.
Yeah. So if the parent function, which it does, look like this, well, this graph would be shifted to the 1 right because of this here. This tells us that h is clearly 1. Because my general form is always a times x minus h quantity squared plus k. So 1 takes the place of h. The minus sign is the same, leave it alone. Since 1 takes the place of h, we move the graph over 1 unit, so over to here. Move it over 1 unit. Then the positive 4, and we see positive k, means that 4 takes the place of k. So this is going to shift up 4 units. So I know already that my vertex is right here. Okay, there's my vertex, hk. Over 1, up 4. That's a positive 1, that's a positive 4. Then I know that the graph has a 2 in front. If there's a 2 in front, what does that mean? As opposed to a 1. Both positive still, but one has a 2 now. What does the 2 indicate on my graph? Part. Niall?
It's going to be narrower.
It's going to be narrower when you see a 2. So if that parent function were correct, if that were drawn to scale, this new answer would be something a little bit narrower. Okay, it wouldn't rise as quickly. But the idea behind that is that you would still be able to figure out the vertex by finding h and k. If you wanted the y-intercept, well, the y-intercept is just going to be 6, right? 2 times 1 squared plus 4 is 6. So maybe not as steep as I drew it, because you want to go through 6, which might be like right over here-ish. How about for intercept form? Intercept form. We did a lot with intercept form. We also talked about the sum and product of roots. What do you know about intercept form? Luke, give me some info about intercept form.
B over A is
All right, so let's take a look at that. Sum of the roots is equal to negative b over a. What was the product of roots equal to? Product of roots equals c over a. And those two statements are definitely true. Well, why is this useful? If you know what the roots are, you could sum them together to give you the value of negative b over a. You could multiply them to give you the value of c over a. And then you can come up with an equation or come up with values for a, b, and c to help you there. So that's one thing, and we'll look at an example of that in a minute. Intercept form. What does intercept form look like again? What does it look like?
ax minus r1 times x minus r2.
Yeah, where R1 and R2 are the... Yeah, they're the roots if this were an equation, right? These are the zeros. R1 and R2 are the zeros of the function, or like the x-intercepts. So in these cases here, we want to think about the fact that, well, what if this had been a value like x minus 2? And x plus 1. Well, we solve this the same way we would solve a regular equation for set equal to 0, because if we want to find the x-intercepts, to find the x-intercept, we set y equal to 0. And in this case, y is really f of x. Okay, as always, this function f of x is really taking the place of the y coordinate. So that's why this is called intercept form, because you literally are given the intercepts in the form of the function. So you plug in a 0 here, and as a result, x equals 2 and x equals negative 1 are my x-intercepts. So you can clearly see here that this 2 takes the place of R1, so 2 turns out to be a root. This was really x minus negative 1 to give me x plus 1, so this is a negative 1 down here. What other info do I know? I have to know something else. What else, Sabine? The average of the roots is the location for the axis of symmetry. That's absolutely right. Remember, the graph is symmetric. So if you have roots on both sides and you average them, you get to the middle. The middle is the axis of symmetry. So average together, 2 and negative 1. What do you get? What do you get when you average together 2 and negative 1? What do you get? I get positive 0.5. It's 2 and negative 1, but yeah, you're on the right track. So if here's a 1 and here's a 2 and here's a, let's say a 1, I've got a root there already, I know that. I've got a root there, and I've got an axis going through here at negative 5. Okay, that's what I know so far. That's what I know so far. Now, I know that I'm going to get real answers for my roots because they were obviously given here. But what else can tell me that? What other information do I still need? And I can figure out that the roots would definitely be real. What else can I find?
The sign of the discriminant.
The sign of the discriminant. Very good, Niall. The sign of the discriminant. Now, it's not in standard form, so A, B, and C would be annoying to have to just multiply it out. So what else can we do? So you can always use the sign of the discriminant. Very good. What else? If I had the axis, what can I get from the axis? Right, the axis of symmetry I'm talking about now. With that piece of information, what can I always obtain? The coordinate for the blank. Vertex. What's the axis of symmetry, Mike? What did you say it was? 0.5. So take 0.5 and plug it in. Plug it into the original function. Plug it in here and plug it in here. Plug in 0.5. You're going to get 1.5 here. You're going to get negative 1.5 over here. Right? 1.5 and negative 1.5. Multiplying them, you're going to get negative 2.25 times 3 is going to be negative 6.75. So when I plug in my axis of symmetry for this example here, okay, again, if I do f of 0.5, I'm going to get negative 6.75. Well, that tells me that there's a coordinate. And that coordinate is located at 0.5, negative 6.75. So going down on the y-axis, continuing this graph, there's 3, 4, 5, 6, 7. My vertex is going to be right here. Okay? So I go down. 1, 2, 3, 4, 5. Oops. 1, 2, 3, 4, 5. Yeah, 6. And there's 6.75. Now, Ben, the vertex is below the axis, right? It's below the horizontal axis here. So how am I guaranteed that I'm going to have real roots if I didn't know that these were the roots? Imagine I didn't know these roots were here, okay? And I just simply look at the original, and I knew the vertex was down here. What would tell me that I'm definitely going to have real roots? A is positive. Very good, Ben. If the vertex is below the x-axis and A is positive, it's got to open up, right? So it's going to cross the axis. If the vertex is above the axis, A's got to be negative for it to cross, to have real roots. Remember, if A were negative in this problem, it would look like this. Just like my hand, it would open down like that, right? And this would never have any x-intercepts, and therefore it would not have any real roots. How about the last piece? Let's find the y-intercept. How do you always find the y-intercept for any function?
So that's equal to 0.
Set x equal to 0, well, it makes it easy. See where I circled the x's? Just cross them off. Make these zeros. So you're going to have negative 2 in this first case, right? This is 3 times negative 2 times positive 1. Agreed? Okay, so you can have 3 times negative 2 is negative 6. Times 1 is still going to be negative 6. So the y-intercept is down here at 0, comma, negative 6. That little blue dot. Thank you. And I can finally do one last thing. There's one more thing I could do. It's very simple to do. Yeah, reflect the y-intercept right over to here. Since this is a half a unit over, go a half a unit over on the right, which should be at 1, comma 6. Okay, again, this is the y-intercept 0, comma, negative 6. This is the axis of symmetry at the bottom here. 0.5, comma, negative 6 point. That should be a point. .75. Okay, and as a result, if 0, comma, negative 6 is there, then we must have 1, comma, negative 6 over there. And these last 2 points, as we know, are negative 1, comma, 0 and 2, comma, 0. So all of our 5 points are labeled. What could we do finally to end this? Just connect it with a smooth curve. So when you're looking at these functions, there's many ways to graph them. If they're given in standard or vertex form, what I recommend you do is you find the x-intercepts, you find the axis of symmetry, you then find the vertex from the axis of symmetry, find the vertex, then you can use the y-intercept and reflect it. All right, that would be the method I would go about graphing anything in standard or intercept form. Okay, if you're going to graph on the test in standard intercept form, find the x-intercepts, find the y-intercept, reflect it over the axis of symmetry, and while you have the axis of symmetry, go ahead and find the vertex. This is enough information to graph any quadratic. If you did not have the roots, if the roots were imaginary, you might only have one, say it open down, obviously. 1, 2, 3 points, and you'd have to connect them like this. And then maybe you could just find more points using a table if you'd like. Okay, that would work as well. You can find the table, find points using a table if there are no real roots to the actual function itself. All right, let's see. Roots are 3 halves plus or minus, God bless you, 1/2 I. All right, those are the roots of the function. And it says, determine a function that has, or determine an equation with the following roots where all the coefficients are integral values, or just determine the equation with the following roots. How would I go about approaching this? How would I go about approaching this? I'm told those are my 2 roots, and we want to come up with an equation. Not a function. Okay, we're not going to need a function here, but an equation that has those two roots. Plug them into intercept form. But now, we could, but they're imaginary. So it's going to get really messy, right? We're going to have x minus 3/2 plus 1/2 I, x plus 3/2 plus 1/2 I. So that's going to be really messy. There's an easier way to do this. Shouldn't this, yeah.
Take negative b over a equal the sum of them, and c over a equal to the product of them, giving you guys values of b and c as the standard form.
Yeah, that works. So use the sum and product of roots. The sum of roots is negative b over a. The product of roots is c over a. We said that earlier. So utilize that. So sum them together. So add the following, right? Add them together first. Do this plus this. When you add two things together, the opposites cancel. So these cancel when you're adding them together. What's 3/2 plus 3/2 is just 3. Okay, and again, this is the sum of the roots. So this is really negative b over a. Negative b over a is equal to 3. All right, now what's the product of roots? How do I find the product? I literally do the same thing, but I put a multiplication symbol. And this is going to be c over a. Where the product of roots is c over a. Well, why is this easy to multiply? What will always happen when you multiply answers like this? Always.
This square of the first value plus, or minus the square of the second value.
Yeah, why? This is an example of what? Yeah, difference of squares, remember? When you multiply two things with difference of squares and you FOIL it, the middle terms cancel. So when you're FOILing this out, you're going to do 3/2 times 3/2, which you'll start with 9/4. Then your outer and inner are both going to give you 3/4 I and negative 3/4 I. Those cancel. Then multiplying 1/2 I times negative 1/2 I is going to give you negative 1/4 I squared. All right, well, I want to simplify that so it looks nicer. What's I squared equal to? Ben? Negative 1. So this is really 9/4 plus 1/4. Make this a positive and drop the I squared. It becomes 9/4 plus 1/4, which is 10/4. 10/4 is really 5 over 2. So we got 5 over 2 as our answer for c over a. And a minute ago we said that b over a was negative 3. Or sorry, negative b over a was 3. So those are the results that we get from these roots at the bottom here. These are the statements we have. Well, how do they make sense? How is this going to be useful for us? How is it useful? Well, Niall, looking at this, right, you see this right here, don't you? What would this tell you? If you saw c over a equals 5 over 2, what would you make? What conclusion? Say again? That it opens up. Assuming that a is positive and you're graphing this, okay, but again, what we're trying to figure out the equation, right? Not the graph. It says find the equation that is used, or that gives you these roots. So we're not really trying to find the graph, but the equation. If I see a proportion, wouldn't I usually equate the tops and equate the bottoms? Right? So what could you say as a result, if that's true?
6c equals 5a.
So you're cross multiplying? Okay, that is true also, but I'm saying equate. Equates. So if I had if I had this. If I had x over 3 equals 1 over 3, what's x?
1.
Why?
Oh, so c is 5 and a is 2.
Okay, so let's start by doing that. That's what I was saying by equate the coefficients, okay? So let's start by writing that C is 5 and that A is 2. If you have a fraction, utilize it first. Equate coefficients or equate proportions. So C is 5 and A is 2. If that is true, what should I do on this side? Right. Plug in A and then solve for B. Okay, that works. So plug in a 2 for A and then solve to see what you get for B. That works. Or you could write this instead of 3 as what over what? 6 over 2, which is the same result you're going to get. Write this as 6 over 2, because A is 2, and 6 would equal negative B, or B would be negative 6. Same thing as plugging in a 2 down here, multiplying by 2, and dividing by negative 1, getting B is negative 6. So again, I would write this as negative B over A equals 6 over 2. Well, A is still 2, that's true, so B is just negative 6. It's the same thing that Ryan said. Ryan, what you said actually works probably even easier. If you plug in a 2 down here, you multiply by 2, you get negative B equals 6, so therefore B is equal to negative 6 as a result. So if we write this out, and it said find the equation with the following roots. Not function, but equation. What would I write as my answer? Find the equation that has the following roots. That was the statement in the beginning. And those roots were 3/2 plus or minus 1/2 I. No? Equation, not function. What would the equation look like? Even though it's not written as f of x, Luca, that would still be considered a function there. That's why I paused you in the beginning. How do you find the zeros of a function, the x-intercepts? How do you find the x-intercepts? Set y equal to 0. So Luca, why don't you continue with what you're going to say, but do what he said.
0 equals 2.
Yeah. Okay. Again, this is the equation whose roots are 3/2 plus or minus 1/2 I. If you were saying find a function with the following x-intercepts, and you did the exact same process, it would work. But in this case, I couldn't say that. Why couldn't I say that? Why couldn't I say, find a function with the following x-intercepts? Because if I could say that, then I would just write f of x here instead, and I'd be done. I'd say f of x equals 2x squared minus 6x plus 5. Why can't I make the statement? There's a specific reason here. The roots were imaginary. When the roots are imaginary, there are no x-intercepts. So you can't start the question by saying, if these are the following x-intercepts, find a function that has these x-intercepts. If the problem had said the following instead, the problem said this. Let's say the x-intercepts were 2 plus or minus radical 5. If I said the x-intercepts are located at 2 plus or minus radical 5, find the function that represents this. Then you would do all the same work we did, and at the end you could write f of x equals instead of 0 equals. Because you could have a function with these as x-intercepts. Okay, you could have a function with those as x-intercepts. But the last thing we had, those could always only be roots of an equation. Roots of an equation. You can't really say that they're x-intercepts of a function because there aren't any x-intercepts for a function whose roots are imaginary. Let's see if there's other stuff I want to pick up on. We talked about domain and range. Right? We talked about domain and range of quadratics. So let's quickly let's say that our vertex of some function, some random function, was at 2, 7. And we know that the a value was negative. If that's true, draw a quick sketch. So draw your vertex and draw a graph that would open either up or down depending on what you think it should be. do something like that, okay? A random vertex, since A is negative, it should open down, right? It should open down. What would the domain be for this graph or this curve? What would the domain be? The domain. Huh?
Negative infinity to infinity.
Why?
Because if there's arrows, so the graph just keeps going.
Yeah, the graph arrows are pointed down and left, down and right, which means that the graph's going to go left forever, and right forever, and down forever. So if it goes forever to the left and forever to the right, the domain is from left to right, right? That's the domain. So it's all real numbers, or negative infinity to positive infinity. So the domain for this function is all real numbers, or as Niall said, in interval form, negative infinity to infinity. What about the range for this function? What would the range be, Kel?
Y is less than or equal to 7.
How come you know that, Kelly? That is absolutely right. How come you know that?
Because the highest point on the graph is 7.
Yeah, the height of the highest point. That's the idea there. Look at the y-coordinate of the vertex. It's 7. So the highest we go is 7. Since it opens down, everything is lower. So everything is less than or equal to 7. Written in set notation or in interval notation. Okay, I put a bracket there because the bracket indicates less than or equal to 7, including 7 on the way down. Let's see what I want to discuss. Yes. So far, so good? Does it make sense? Got to make sure that we know this for tomorrow, guys. It's a short test, but when it's a short test, it means that a small error has a big significance, right? So we talked about what negative b over 2a is, what c is, what b squared minus 4ac. The discriminant has effect on the graph. That's positive, you have 2 real roots. It's negative, no real roots. It's 0, you have a tangent there. Let's see. So we, sure. Let's do an example of a word problem. That'd be good. So we did an example in class where, in the word problem, our attempt was we wanted to maximize like an area of a geometric figure, or we wanted to maybe minimize the cost of something. So let's say that the let's say that the revenue brought in at a company, the amount of money that the company makes, or that they turn in, is represented by x squared plus 3x plus 5. And the cost at this company is represented by 2x plus 4. And you're told that the amount of profit that a company makes is the revenue minus the cost. Okay, the profit is defined as the revenue minus the cost. And your goal is to maximize the profit. God bless you. Okay, maximize the profit. So pretty much come up with what the maximum profit would be. Well, if profit is defined as revenue minus cost, how should I begin this? What should I write? Profit is revenue minus cost. Revenue is one thing, cost is another thing. What should I do? Right. So what should I write? Go ahead, tell me. Good. So I start with that, right? Substitution. Sometimes you guys look at me like I have like 12 years or something going on crazy in my head. Right? Plug in for R, plug in for C. One goes there, one goes there. Let's just subtract the two of them. When we subtract the two of them, we get the profit function. So therefore, the profit function is defined as x squared plus x plus 1. I know that simply because I have 3x here, and minus 2x is 1x. 5 minus 4 is 1. If I want to maximize this, I want to maximize the profit. Should be... This should be a negative here. Make that a negative, sorry. If I want to maximize this profit, what am I looking for? What am I looking for if I'm trying to maximize this? How do you find the maximum of something when it's a quadratic? What are you really looking for if you're trying to find the maximum? Or the minimum? The what? The vertex. Ben, how do I find the vertex? Find what? X and Y? What do you mean X and Y? X and Y what? Okay, so how do I find X and Y? Here's my function right here, right?
Oh, you said x equals 0 and y equals 0?
That'll give you the X and Y intercepts. Not the vertex, right? If I drew this as a graph, if I just sketched it real quick, right? Hypothetically. That's what it would look like, right? And I want to find this location right here, the vertex. So what should I find first that might help me find the vertex?
Axis.
Which is equal to? X equals, somebody help me out? Negative b over 2a. Okay, you gotta memorize this stuff, come on. Negative b over 2a. So negative b is 1 over 2 times a is negative 1. Negative 1 over negative 2 is 1/2. So the location of the vertex is 1/2. The height of the vertex, though, is what we're looking for. We're not trying to figure out, like this might be time after like 1/2 of a year. Maybe they profited. Or maybe after 1/2 of a million products are produced, they got a maximum profit. Whatever caused this to be a maximum profit. But the idea behind it is that the X value really means nothing. The X value tells you how many products are made or at what time it would be a maximum. It's the Y value that actually tells you the maximum or the minimum. So how do I find the Y value? Mike, what do I do to find the Y value now? That would give me the x-intercepts if I set y equal to 0. That would give me the x-intercepts. We just found the x value. X equals negative b over 2a gave me the axis of symmetry, and we wrote that as the x-coordinate for the axis of symmetry and the vertex. We want to figure out what the y value is for the vertex. We did this in the last example, Mike. We just wrote it down. Are you focused? Come on. If you want to find the y-coordinate and you have the x-coordinate, just do what with it? Yeah, just plug it in. So you've got 1/2. Plug in 1/2 into the profit equation. You guys got to focus. Come on. These are not brain busters that I'm giving you right now. Take this 1/2, plug it in here, plug it in here. The profit after 1/2, maybe 1/2 a million products are produced, maybe again 1/2 a year has gone by. We don't know what X represents right now. It wasn't given. But our goal is to find the actual profit. So it's going to be the quantity negative 1/2 squared plus 1/2 plus 1. Well, you have to do 1/2 squared and then put the negative sign in front of it. So this becomes negative 1/4 plus 1.5 which is 1.25. Now maybe the units on that profit are $1 million, and maybe the units on the half was millions of units. So after 500,000 units of this product to produce, they make a profit of $1.25 million. Okay, so that's what goes right here. And your goal was to figure out what the maximum profit value is. It is 1.25, whatever the profit is, $1 million or $1.25 billion or whatever it could be. All right? We're going to run out of time in about 3 minutes. I'm trying to think of other stuff that we had in the test. You should definitely be able to do a problem like this, where you have, at another point, finding the actual function that works from it. So say you're given, and these are integer roots. Say you're told that the roots are 3 and 8. 3 and 8, okay? And that the point 4, 6 is on the curve. Okay, you're told those are the x-intercepts or the roots. And you're told that 4, 6 is on the curve. How would you go about figuring this one out? The sum and product of roots thing works again, but that's more work than necessary. There's an easier way to do it with this. This again works when the roots are integers. When the roots are like binomial conjugates, like 2 plus or minus radical 5, or complex conjugates, use b over a, negative b over a, and c over a for product and sum of roots. What would I use here? Sabine, what would I use? Yeah. What would it look like? Go ahead.
6 equals a 4 minus 8
You're plugging it all in at once. That works. Okay. Can you do it one step at a time so others stay with you? Just plug in the roots first.
x minus 3
And,
and x minus 8.
and then what Sabine noticed, obviously, a minute ago was that 4, 6 is on the curve. If a point is on the curve, it satisfies the actual function. So 4 can go in for x here and here. And 6 can go in for y here, and you can solve for a. This is an easy problem, but some people struggle with it still. As a result, we're going to get 1 here times negative 4. So we're going to have negative 4 into 6 is going to give us a equals negative 3 halves, or negative 6 fourths. If a is negative 3 halves, our final answer becomes negative 3 halves, x minus 3, x minus 8. So this function right here would have the roots of 3 and 8. You can see that right here. Right? This is a 3 right here. So we know that one of the roots is clearly 3, and one of the roots is clearly 8. This negative 3 halves for a came as a result of plugging in this point. This goes in for x in the function right here and right here. This goes in for y right over here, giving us this line, allowing us to solve for a. We did one of these in class. We did an example of it. That's a good type of question to expect. And maybe look at one of your geometry examples that we did. Okay, we did one with like a house where to maximize the amount of area available.
Electrical circuit where they give you.
It could be any circuit, yeah. I could give you a function that says anything and say find the maximum. The goal, though, or the minimum, is to find the axis symmetry and then just find the vertex. It does not matter. It could be any application type for a word problem. I'll probably give you one of the functions. The other time I'll give you geometry and you have to come up with the function yourself for it. Okay?